Hello students, welcome back. In this module, we are gonna do some very important derivations for general solutions. You remember general solution? They are the all values of x. So, if I say sin x is equal to 1 by 2, for that case on x and y axis, we know that sine of pi by 6 is nothing but 1 by 2. So if I keep on writing all the values of x such that it is positive and it satisfies the sin x equal to half equation. The first value is when x is equal to pi by 6. Moving ahead, in second quadrant also sign value is positive. By allied angles I can say sine of pi minus pi by 6. So after taking LCM it would become sine of 5 pi by 6 and which is equal to half. So I can also say x is equal to pi by 5 pi by 6. In third quadrant sine is negative, so I would not consider that quadrant. Also in fourth quadrant sine is negative. So over here we have completed the one cycle of 2 pi. Again entering in the cycle it would be 2 pi plus pi by 6. So after taking LCM it would be 13 pi by 6 and which is equal to 1 by 2. So if I again keep on writing the values of x as 13 pi by 6 and so on. In other words, if I keep writing all the values of x for which sin x is equal to half, can you observe something? Yes, you see that the solutions of a trigonometric equation which are generalized by using its periodicity are known as general solution. That is, the every function which repeats after a period and you consider all the values using its periodicity are called as the general solution. Now, let us consider on x and y axis. We know that sine 0 is given by 0. We also know sine pi is given by 0. We also know sine of 2 pi is given by 0. So if I keep on writing this, you know that sine 0 which is equal to sine pi which is equal to sine 2 pi, 3 pi, 4 pi, 5 pi. You observe something? Yes. So students, the integers, that is n pi is the factor over here. So when n is equal to 1, it becomes sine of 1 pi and you get 0. When n is equal to 2, it becomes sine of 2 pi and it is equal to 0. If I generalize this term, I can say that sine of n pi is equal to 0. Now let's see for cos function. We know that cos of pi by 2 is given by 0. Also cos of 3 pi by 2 is given by 0. Once the cycle is completed, again cos of 5 pi by 2 is nothing but 0. So if I keep on writing, I get cos of pi by 2 which is equal to cos of 3 pi by 2 which is equal to cos of 5 pi by 2 and so on. And for all these values, answer is 0. So if you generalize this term, the equation would be cos of 2n plus 1 pi by 2 which is equal to 0. Now if you put n as 0, so the equation would be 2 into 0 plus 1 would be 1. So cos of pi by 2 which is equal to 0. If you put n is equal to 1, equation would be cos of 2 plus 1 into pi by 2. It is nothing but cos of 3 pi by 2. If you put n as 2, it will become cos of 5 pi by 2. So for all this series, the generalized formula would be cos of 2n plus 1 pi by 2 is equal to 0. Now, tan theta would be equal to 0 only if theta is equal to n pi. How? Let's see. You know that tan theta is equal to 0. We also know tan theta can be represented as sin theta upon cos theta. So tan theta would be equal to 0 only if sin theta upon cos theta would be equal to 0. if cos theta goes on the other side, equation would be sin theta is equal to 0. We just now did this equation. Sin theta is equal to 0 only if theta is equal to n pi. So hence, using this condition, I can say that tan theta would be equal to 0 only if theta is equal to n pi. Always make the note of the generalized formulae of sin theta, cos theta, tan theta. The reason is that we would be requiring this in various problems. See you in the next module. Thank you.